Hello, in this video, we will learn the time value of money concept, specifically the future values of different kinds of annuities. First, we'll start with what is an annuity. An annuity is going to be a series of cash flows of the same amount, which is key, same amount, that is received or paid each period. So some examples of that, if we have interest payments on a bond, so let's just say we have to pay back, or we can receive bond if we sell bonds to someone else, $1,000 a year for 5 years. An annuity would be lease payments on equipment. We're paying the landlord or the lessee, the lessor, $500 a month for the next 30 months. And service contracts with customers, whether they pay us monthly or quarterly or semi-annually or annually, but it's the same amount every single period. So the thing to know about annuities is there's two different kinds. One is the ordinary annuity, and that occurs when the cash payments are made at the end of each period. An annuity due is when the payments occur at the beginning of each period. Let's start with an example of an ordinary annuity. An installment note payable might require the debtor to make 3 equal annual payments, with payments due at the end of each year. So end of each year means it's an ordinary annuity. It's when you make the payment at the end of the period. So we know we're talking about ordinary annuity. And let's just do a little timeline here where we have today, and we make our first payment at the end of year 1, end of year 2, and end of year 3. Annuity due is when we make the payments at the beginning of the year. So a 3-year lease of a building may require each year's lease payment to be made at the beginning of the year. So let's say we have a lease agreement and it's for 3 years, and let's just say today's 1/1/X1. We make our first payment today, our second payment on 1/1/X2 or 12/31/X1, doesn't matter, and then 1/1/X3 we make our third payment, but our lease is for the entire 3 years. So we still get to lease the property or the building for 3 years. So we get to lease for 1, 2, 3 years, but our last payment was right here. Let's look at this concept check. Justin investor wants to calculate how much money he needs to deposit today into a savings account that earns 4% in order to withdraw $6,000 at the end of each of the next 5 years. He should use which present value concept? And when they say concept, it's really going to be the which factor table. So first we know $6,000 at the end of each year. That tells us that it is an ordinary annuity. So immediately I can, it's not the present value of $1 because that's just for a single amount. And the future of $1 is also for a single amount. And at the end of each period is an ordinary annuity. So I know that it is going to be C. Another concept check, the Not Worth Getting consulting company purchased a machine for $15,000 down and $500 a month payable at the end of each of the next 36 months. How would the company calculate the cash price of the machine, assuming the annual interest is known? So we're not being asked to calculate the purchase price, but it just says we do know what the annual interest rate is. So it should be noted that we purchased a machine with $15,000 down. So that means we don't have to present value or future value that. We know we're going to pay $15,000 plus, right, and $500 a month payable at the end of each of the next 36 months. So we're going to find out at the end, we're going to have consistent payments made, not just a single payment. So that means the 15,000 plus the present value of 18,000, which is that would be present value of $1. That's what it's talking about. That's not what we're doing. So that's out. $15,000 plus the present value of an annuity due of $500 for 36 periods. Well, annuity due would be at the beginning of the year, at the beginning of the period. So that's out. Here's just a plain simple 15,000 plus $500 a month for 36 months doesn't take any sort of time value of money into account. So it's going to be D, 15,000 plus the present value of an ordinary annuity of $500 for 36 periods. There you go. So, okay, let's look at the future value of an ordinary annuity. Remember, that's making the payments at the end of the period. End of the period payment. Okay, suppose you want to accumulate a sum of money to pay for grad school. Rather than investing a single amount today that will grow into future value, you decide to invest $10,000 a year over the next 3 years in an investment account paying 10% interest compounded annually. You decide to make the first payment to the account 1 year from today. How much will you accumulate in the account by the end of year 3? So let's just take a visualization of what is happening. So it says, okay, we're here today, and you're going to make $10,000 at the end of each of the next 3 years. And because it's compounded annually, when you look at our factor tables, our N, our compound period, is 3, and our interest period is 10. I just want to point out that I just want to quickly just point out that if the compounding was, let's just say, semi-annual, right, then our N would equal 6, and our number of compounding period would equal 6, and our interest would equal 5. That's just an FYI. Okay, so let's just continue with this problem to see how we can do it. There's 2 ways. The first way is the way we already know. The problem says that we are going to make a payment of $10,000 at the end of year 1, 2, and 3. Well, we already know how to do future value of a single payment of $1. So we can look at our first payment, $10,000, and say, okay, what's the future value of $1, assuming interest I equals 10, the interest is 10, and our N in this situation is actually 2 when we look at our factor tables. And that's because we're looking at this, our first payment is right here, and how many periods are we calculating to get to the end of year 3? We have 2 periods there. So that's how we could do, if you look at the factor table, future value of $1 with I equals 10, the 10%, and the number of compound periods is 2, you'll get a factor of 1.21. Then we make another payment, right? Our second payment is $10,000 at the end of year 2, and we can see what's our future value at the end of year 3. So in that situation, we only have a single compound period. So we would go to our future value of $1 table and look at I equals 10%, our N equals 1, and we get 1.1, and we say 10,000 times 1.1 is 11,000. I didn't go through this, but 10,000 times 1.21 equals 12,100. And then our third payment is already made at the end of year 3, and we're trying to find the value at the end of year 3, so there is no factor to apply. It's just 10,000 times 1 equals 10,000. You add up all those amounts, and you figure out that if I make a payment at the end of each year of $10,000, assuming a 10% interest rate, at the end of the third year, I will have $33,100. Well, that's a lot of work. So thankfully, we have a factor table to calculate the factor future value of an ordinary annuity. And we can go to that table, and we could take $10,000 times the future value of ordinary annuity. Let me go to my factor tables right here. And this is the same tables I've used in previous videos. So again, note which table you're using. This would be the future value of an ordinary annuity. This is what's the interest rate? N equals 3, right? We have a 3-year period and interest rate is 10%. So I'm going to go to N equals 3 because I have 3 compounding period at 10% is 3.31. So if I take $10,000 times the 3.31, I will get $33,100. So note, it's the same number as when we calculated the, when we did the future value of $1 separately for each one of those payments, we got $33,100. But we have a factoring table for future value of an ordinary annuity that we can do the same thing. Similarly, when we have future value of an annuity due means the payment is at the beginning, beginning of the period. And so suppose you want to accumulate a sum of money to pay for grad school, rather than investing a single amount that will go to future value, you decide to invest the $10,000 over the next 3 years, $10,000 a year, which is what makes it an annuity, in an investment account paying 10% interest compounded annually. So far our facts are the same as the prior example, except you decide to make the first payment to the account immediately. How much will you have available in your account at the end of the 3 years? So let's look at our visualization again. So in this example, we're going to make a payment. Our first payment will be made today. Our second payment will be made at the end of year 1, and our third payment will be made at the end of year 2. And we want to know how much will we have at the end of year 3, assuming a 10% interest rate. So our number of compounding periods is still 3. 1, 2, 3. So we can still use our future value of $1 if we wanted to, and calculate the future value of $1 factor table and calculate each $10,000 payment separately. If we were to do that, the first payment of $10,000 was paid here, and we're trying to get to here. So we would use a 10% interest rate, and the number of compounding periods would be 1, 2, 3. So that's here. So in this situation, we would go to future value of $1, N equals 3, I equals 10, and you would see the factor is 1.331. And I take 10,000 times that factor, gives me $13,310. I could do the second payment right here. Right here is my second payment. And I say, okay, well, how many periods is it going to compound interest? In this situation, it's going to be 1, 2, and 2 periods. So I would look at my factor for N equals 10, N equals 2 for 2 periods, and the interest rate is still 10%, and I'll get this factor, multiply 10,000 to get 12,100. And then my third payment, which is made at the end of year 3, it will only be compounded for 1 year. And if you look at N equals 1 and I equals 10, that factor would be 1.1. And you multiply the 10,000 times 1.1 gives you 11,000. When you sum all those 3 numbers, you would get $36,410. That's how much you would have at the end of 3 years. Or instead of going through this whole process, you could look at the table called future value of an annuity due of $1. So it's really key that you pick the right factor table, because we have the future value of an ordinary annuity, but this one is annuity due because the payments are made at the beginning of the year. So let's just quickly go to that table right here. So see, this is the future value of an ordinary annuity. That's not what we need. we need the future value, let's see, the future value of an annuity due. So this is not it, and I have to keep scrolling, and here it is. Future value of an annuity due for n equals 3, because we're making, we have 3 periods, at 10% is 3.6410. And I go back here, and I look, I just multiply $10,000 times the 3.641 factor, and I get that same amount. Okay, let's do this quick problem. I like it because it's kind of different facts that we've had so far. Our right plans to make quarterly deposits of $200 for 5 years into a savings account. The first deposit will be made immediately. So right away, we know it's going to be an annuity due because we made the first payment at the beginning of the period. The savings account pays an interest rate, an annual rate of 8%, compounded quarterly. How much will Wright have accumulated in the savings account at the end of the 5-year period? Well, we're going to take the $200 times some factor, right? And the question is, what's the factor? Well, let's look. We already said that the first deposit will be made immediately, so we know it's going to be an ordinary annuity. So let's just cancel out anything with a future value of an ordinary annuity. I'm sorry, made immediately, so we know it's going to be annuity due. Now we narrowed it down to 2 options. Because it is compounded quarterly, which means we have 4 periods a year, we have to take the 8% and divide it by 4. So our interest rate will be 2%. We'll look at the future value of an annuity due of $1 at 2%. Additionally, you have to look, this is a 5 years worth of deposits made quarterly. So it's for 5 years, but 4 times a year. So you're going to make 20 payments. So it's for 20 periods. So you're going to use this factor. So 200 times 24 times 200 times 24.7833. And that's going to give you 49.57, which is right here.